everyone, Adam here from Vector 3D, back again at Formnext 2019, and we're here at the Dyze Design booth with Philip from Dyze Design. Philip, can you just start off by letting me know what it is you do at Dyze Design?
So at Dyze Design, I'm the CTO, so I'm in charge of new product development, and I work with R&D stuff.
So this is a fairly large looking product we have in front of us. What is it? What's it for? What does it do?
So it's called the Pulsar. That's our new pellet extruder. So we try to design it to make it as light as possible so that people can use it on a 3D printer. So the whole thing is about 2.5 kilogram in weight, and it can output up to 2 kilograms per hour of PLA.
That sounds like quite a lot of material. This is clearly aimed for much more industrial market than your home consumer, right?
Yeah, definitely. So maybe some people can make big stuff out of it. So I think definitely it's more like a big size printer where you want to have more than 10 kilos for each part you print.
So let's get into some technical details then. It looks like quite a feat of engineering. Let's start at the bottom, I guess, with the nozzle. That's clearly not any standard nozzle. What can you tell me about that and the design that goes into it?
Yeah, so with the screw, we had to think differently with the nozzles because you cannot retract with the screws. It cannot suck material in. It can only generate pressure inside. So inside the nozzle, we have some kind of blocking mechanism. So as soon as we stop generating pressure with the screw, there's a mechanism that moves and blocks the output. So that way, with this design, we can still use the same kind of retraction, but it's not done with the slicers by moving the filament upwards. It's just done by rotating the screws.
Okay, so from the outside, it does just look like a plain block of material, but clearly it's not just that. It is a bit more complicated. So you mentioned there that there's a screw. Is that the mechanism for driving the filament? How does that work? What is it? What does it really do?
Yeah, so the screw is a custom design for us. So right now it's in a beta phase. So we have a general screw. So it's going to do good with most filament, but with some technical stuff with the PEEK and the PEI, it's not going to be the best screws, but it's going to be able to extrude anyway. So it's made from alloy steel, so chromium and molybdenum steel. It has a heat treatment and it has a hard chrome plating over it. So we designed it to be very durable, so you can put like highly filled pellets inside this extruder. It's not going to wear out.
So is that suitable for things filled with carbon and other fibers and things like that?
Exactly. So one of the big advantage by using pellets is that you don't only pay less for your pellets, but also you can have them charged with more fiber content. So we have seen wood pellets with 50% content of wood.
I guess with a larger nozzle and that as well, you don't have to worry so much about the fibers clogging the nozzle, and you can have longer fibers, which therefore increase the properties a little bit better.
Yeah, totally. So right now our biggest nozzle is 5 millimeters. So you could print some big chunks of wood inside it. And the smallest one we have is 1 millimeter for now.
So as you mentioned, it's a pellet extruder. So somehow you've got to get your pellets to here. How do you go about doing that?
We use a venturi system, and when the solenoid valve checks in, your airs will push the pellets inside. So when we run, probably every 4 minutes, there are new pellets coming in.
So the pellets kind of get caught up in the air as that's moving in, and that is what pulls them up. Bit sort of like a vacuum, sort of like a kind of Bernoulli sort of flow.
Yeah, exactly. So it's a very simple but effective solution.
So if by any chance somebody does want to try and fit this to their printer, I'm sure there are a lot of industries out there who might be interested in this. What sort of price point and availability are we looking at for this?
So right now we are running a beta program. So you have many options. You can get them for around 3,000 euros, or you can get what we call a buy one, get two. So you can get a better unit, and then when we are ready for production, with all the sensors are integrated, you will get a final version unit. And this one is around for 6,000 euros.
6,000 euros. I guess it seems a lot in a consumer market, but in an industrial market, I guess a higher cost and higher quality in the long run means lower cost per part that you're printing. Right?
Yeah, exactly. And you have the advantage of printing big parts fast too. So that has a big advantage.
Excellent. Well, thank you very much for your time today, Philip. Hope you have a great rest of the show. Now we're going to switch over to Craft Unique. Hello everyone, Adam here from Vector 3D, here at Formnext 2019, and this time we're at the Craft Unique. Craft Unique.
Craft Unique.
We're at the Craft Unique booth with John from Craft Unique. John, would you like to just introduce yourself, what you do at Craft Unique?
Sure. Thank you, Adam, for doing this. Craft Unique is, I'm the head of sales in North America at Craft Unique. We are a company that was established in 2014. Since then, we have established ourselves as a quality 3D printer manufacturer. We've delivered throughout Europe, down in Africa, across in North America, and expanding very rapidly. Our reputation is quite good for building the tank. And after those 5 years of production, what we've done is we launched the brand new Flow Generation 3D printer. It has two key features that are very unique in this space. It is the largest IDEX 3D printer available in the marketplace now. It's plug and play. We also are the only manufacturer to offer 5 years warranty or 5,000 hours. These are unprecedented and they speak to the confidence of our product.
So with those kind of stats, you're definitely targeting an industrial market and more up-end rather than the consumers looking for £300 printers.
Absolutely. We always believed that a 3D printer experience should be a user-friendly experience, and at the same time, it should be geared towards that industrial side. What we've done in the past, our educational vertical is very robust, where we've done it with the previous ones. And at the educational vertical, that level of user friendliness, if it is available at the industrial level, it is incredibly important. And that's exactly what we did. So we have a very user-friendly machine in that sense. The IDEX 3D XL, the largest of our printers, can do, in the IDEX mode, can do parallel mode, can do mirror mode, can do two types of filament mode, and at the same time, without too much complexity. The nozzle hot metal end, for example, can go up to 300 degrees C, which gives you all the filaments that you can do out there, including carbon fiber.
So do you have the hardened nozzles to go with that as well, or are you just working on brass nozzles at the moment?
Yes, we do. We have both nozzles as well as the hardened steel nozzles for that one as well. We got a unique proprietary design for the bed. It's a semi-automatic bed leveling, and
there's some user interaction with that as well as some automated side.
That is exactly right. The one thing that is beautiful about this one is it's a heated bed that goes up to 110, so the prints will stick even in a large print area, especially in the XL. And at the end of it, you have a removable plate that is coated with Kapton for a very smooth finish at the bottom, and then it's very flexible, so it pops up right away in that sense.
So that's a spring steel sheet, is it? I think there's quite a lot of those starting to pop up around the industry.
Exactly. The one differentiator is we have a Kapton film on there, which preserves the heat during the heating process, so it sticks very well. But at the same time, when it cools off, it's much easier to pop out.
So given that a range of consumer printers, especially, I mean, the Mark III comes to mind immediately, having a lot of features in terms of power outage protection and things like that. Do you have features like that on your machines as well?
Absolutely. Again, user friendliness is key, and minimizing the damaged prints is quite important to us. So what we do is we have a filament sensor. In case of an error in the print, power outage, it just stops. And that way you get to save your print. It's very important for us that way. The other thing is it also has a function to print, pause, resume, in case you want to check on these filaments. The good thing is everything is Wi-Fi connected, and you don't have to be there with a printer when it's printing. You got a camera that monitors that. If an error takes place, you get an email.
So what board is it in the machine that's doing your kind of camera and Wi-Fi and screen and things like that?
Thank you for asking that. It's Raspberry Pi. It's the latest and greatest for in terms of enhancements. So we're building this for growth. We're building this for the future. We have one for everyone in terms of machines. We still have our smaller craft bots for the makers and the hobbyists out there, and they are just as user-friendly, just as robust, and you can get all the bells and whistles of the features that we just talked about.
So what's the name of the range for the consumer level? Like, I think it's around $1,000 US, is that right?
We just relaunched and upgraded our basic CraftBot Plus. And what we did now, it is hot metal ends with a new bed design with the Kapton that we had talked about, with 5-year warranty at $1,500.
Okay, John, thank you very much for your time today. It's been great talking to you. Hope you have a good rest of the show.
Thank you, Adam. Really appreciate the time. Thank you very much. Cheers.
Thank you very much for watching. Don't forget to subscribe for more content from Formnext 2019. I'll see you in the next one.